This video is going to address the issue. Given the global form of the polynomial function, how do we obtain the local form? And we need the local form if we're going to find the zeros. That's why this is important. Okay, and this is a problem, and we don't necessarily have a great solution for it. So again, just reviewing, the global form is what I'm referring to as the definitional form, right? So I have it in the form of, well, this form. And the local form is the factor form. Again, global refers to that's where I get the asymptotic information. And local, the factorization form, gives me the zeros, which is local information. Okay, so here's an example. Here's a pretty typical example. This is what you need to do. So we're going to use polynomial division. So with functions, we know how to add, subtract, multiply, and divide. Well, specifically for a polynomial, we're going to divide like this, okay? So here's a typical example. So I'm given the global form of a polynomial. I don't like to write P3 because it's a third order polynomial. It should have 3 zeros. Notice the issue here is, so we're going to use polynomial division as the tool, and I'll show you how to do that, and we're going to factor this. So they tell us x equals minus 1 is a 0. The problem here is in order to start the machine, I need 1 0. And you can say that defeats the point. And yes, it does. I don't have a great answer. I just don't have a great answer. So if you give me a 0, I can hopefully get the other 2 zeros. That's the idea here. But you have to pay me first, right? I need 1 0 to begin the process. That's the key. Now, if they don't give you a 0, you have to guess one. I mean, you have to just guess. Now, if you're guessing by hand and not using a computer, of course, it's going to be one of the basics. You guess maybe 0, 1, 2, right? Minus 1, minus 2. It's not going to be something like minus 2, 1, 6, 1, 4. It's going to be something easy. But in order to start the process, you have to have a 0. You have to have 1 to begin. So you have to use B, right? You have to pay, set up something to start this process. All right. So that's a 0. So let me show you how this is going to work. Yeah, again, you need a 0 to start, and that's not good. Yeah, it's not good. You got to keep a angry face. So here's a solution. Okay. Now here's the process. Here's my polynomial, and I want to factor it. So that's my global form, and I want to factor it. And I'm going to take this as my term. Now this is a mistake people make. Notice it's x plus 1. Why is it x plus 1? Because I need this, and then, okay, that's my quadratic term that I want to get. And then hopefully I can factor that using quadratic formula, or just factor it. But why is it x plus 1? This is the most common mistake people make. Look, it's x plus 1, why? Because I want x plus 1 to be 0, because I want to find the zeros, right? And then if x plus 1 is 0, notice x equals minus 1, which is what we started with. So you're really working backwards, right? If x equals minus 1 is a 0, right? Is a 0, then x plus 1 is my term. So you're working backwards. X plus 1 is 0. X equals minus 1. So be careful. The term is x plus 1, not x minus 1. And what I want to do then is I want to find the quadratic over there. Okay? So that's x plus 1. Now, if I want to solve for the quadratic, I'm just going to divide everything by x plus 1. Just divide clear across by x plus 1. Right? And notice with that, so I'm dividing everywhere by x plus 1. And notice that gives me my quadratic. That's what I want. Then I'll have to factor that. So in order to get this quadratic, what do I have on the other side? I have polynomial division. A polynomial divided by a polynomial. And that's what we're going to look at here. In this lecture, we're basically explaining how to do this. It's a process, right? You learned long division a long time ago. Right, how to divide 28 by, what, 3 or something, right? I mean, you learned long division a long time ago. But that's just it. It's just for polynomial division. It's the same process. So if I want to find that quadratic term so I can factor, I have to do polynomial division. So this is how you set it up. Okay, that's what I need to divide. Okay, so let's set it up over here. So when I write this, I want to set up in this form. That's just a process, and you just need to practice a few. I mean, you don't need to do 80 problems. Practice a few problems, be organized, and you'll be fine. So let's look at it. I have x plus 1 on the bottom, so that goes outside. And my numerator goes under the bracket, right? Okay, just the way you did division with numbers a long time ago. All right, let's do it. So that's what I'm going to get out of this. I'm going to get my quadratic out of the top. Okay, that's what the answer is going to be to give us. Okay, let's look at it. So okay, that's my quadratic. Right, okay. Now, what I have is, what I would have to do first is I have an x3 here I have to be concerned with. And what I'm going to use is I'm going to use this x. I'm not looking at the 1 there, just look at the x, and I need an x3. So what do I have to multiply x by to get an x cubed? Right? Just the x squared. Right? So, notice how I'm going to organize this. I just want to point this out. You have to be organized or it really runs them up. Everything that's x cubed is going to stay here. Everything that's x squared is going to be up and down here. Everything that's going to be an x is up and down here. Everything that's a constant is going to be up and down here. Okay, so be organized. It really helps. It's a very mechanical process we're doing here. So I have x squared. I'm going to multiply it by x plus 1, and I get this. Now, how did I do that? X squared from the top. X plus 1 is that term, and I get this. Right? So I have to make sure I match up my x cubed term. You have to match that up. That's what's important. The first one has to always match up. Has to. So I take x squared times x gives me the x cubed. That has to be match up. And x squared times 1 gives me the x squared. That's just whatever comes out there. Okay, so I don't need all that. So if you can do it in your head, that's fine. And then we subtract it. Right? We're doing the division. We subtract it. I mean, if you just go back and practice long division, that's how you did it. So I'm going to subtract. I like bringing the minus sign in, right? Because if you don't bring the minus sign in, you risk algebra mistakes. So the minus sign came in. And then I'm going to drop the brackets because I don't need it. Be careful here. It's a formal procedure. It means it's a procedure in form. You just follow the steps mechanically. We'll practice. So I'm going to subtract this. So x cubed minus x cubed is 0. You have to get a 0 here, or you did it wrong. You have to get the 0 there, or you made the wrong choice. It always has to 0 out the first term. Now you just subtract this and you get what you get. X squared. 2x squared minus x squared is x squared. Now be careful with signs. It's very easy to mess up the signs here. Okay, so that first turn of the wheel is done. Now I'm going to just bring down this term, and I'm going to bring down this term. Okay, and now we start the entire process again. So the wheel, I think of one of these archaic things. You're cranking the wheel, and all this machinery is turning. So we're on our second crank of the wheel now. So I'm going to look at this. Okay, so again, I'm going to match up my x squared. And I have an x available. So what do I multiply x by to get x squared, right? What do I multiply it by? X. So x times, see again, I'm going to have all my x cubed terms, all my x squared term, all my x terms, and my constant terms. So it's x times all this gives me that. Okay, so take x, take this, multiply them together and get that. So x times x gives me the x squared, and the x times the 1 gives me the x. Again, when I figure out the x, I only check I have to match the x squared term. The rest is whatever it is. So that's what I have. Then I subtract. I'm going to move the minus sign in, right? Move the minus sign in so you don't make an algebra mistake. Now I'm going to drop the brackets, right, because they just get in the way. So it just looks like that. And then I'll subtract them. So again, this has to be 0 or you did it wrong. You always have to cancel out the highest order term. You have to always cancel that or it's not correct. right? And that's how I looked and got x, because I'm trying to use x times e. In the x plus 1, I only look at the x. X times that x gives me the x squared. I have to cancel that. So that checks out. And then the rest is what it is. It's going to follow. Minus 5x minus 1x is minus 6x. And then I bring down, okay, so that's done. Now I'm just going to bring the 6 down, minus 6 down. And there we are. And the wheel starts again. I got to crank the machine up one more time, right? I've got to crank up the machine one more time. So again, I'm only trying to match the first term when I make my decision. I have a minus 6x. What do I multiply this x by to get minus 6x, right? I only try to match the first term, right? So what do I need to multiply by? Right? Minus 6. So minus 6 times that x gives me the minus 6 here. That's how I choose that. Okay, minus 6 times this gives me all that. Right, write it out. Minus 6 times all that. Minus 6 times x gives me minus 6x. Minus 6 times 1, minus 6. Okay? Now I have to subtract this. So just put the minus sign in, right? Right? I had the minus sign on the outside. And I want to put it in distributed. Drop my brackets. Okay, that's why we'll put these together. Add this together. So minus 6 times minus 6x added to 6x is 0. Now again, that has to be 0. That has to be 0. This is going to be what it is. For factoring, for our purposes, I want to stress this. This doesn't always have to be 0. We'll look at an example at the end. And there's some in the homework, whatever. Whatever. But for our purposes of factoring, this has to come out to be 0 or it won't work. It has to come out to 0 or it won't factor correctly. Okay, so for our purposes, if we're going to factor and find the zeros, this has to be a 0. Has to be. Check and check. We're good. So notice we're feeling it. Right? That's what we got for our quadratic. That's what we wanted over here, right? That's what this is. This is the polynomial division that gives us this. And that's what I want here. So let's just put that in here. Bam. So we crank the wheel, and this is what we got. Now the question is, can you factor it? Well, it's a quadratic. So you can always factor it using quadratic formula, or hopefully you can just factor it, right? So that's the issue. If it's a quadratic, you can. If this was a cubic, you'd have to have another 0. I mean, it's difficult. It has to be a quadratic, and we can factor it. Otherwise, it's a problem. So look at this. Can you factor it? Again, no. You always have quadratic formula if you need to. But just try to factor it. I mean, everything doesn't have to be, you know, I mean, polynomial division is hard enough, right? So I factored, right, these two terms. I'll replace this with those two terms, and bam, look, we have the local form. We have the local form. So in order really to get the local form, I can't get a complete answer. You have to start me off with a 0. If it's more than a quadratic, you have to start me off with a 0, and then we can crank the machine up and see what we can do. And it's not a completely satisfactory answer. It really isn't. So we have the local form. So what's the obvious question? Find the other zeros. And that's typically how things are going to be worded. I'm going to give you a polynomial. I'm going to say find all the zeros. Okay, that's the idea. So I give you 1 0 to start the process and ask you to find the other zeros. Now it's a cubic. It's a third order, right? Polynomial function. So we know it has 3 zeros. Right? We talked about that. A third order quadratic has 2 zeros. They could be repeated. They can be complex numbers, right? A third order has 3 zeros. Right? They can be repeated, they can be complex numbers, but I have 3 zeros. Okay, solution. Here's my local form, right? I need the local form to find the zeros. If I want it to be 0, I set it equal to 0. So I have A is 0, and or B is 0, and or C is 0. And that gives me the zeros. There's the 1. Now I knew I already had this one, right? I knew I had this one. Here's my other one, and here's my third. I have to have 3. And again, they can be complex numbers. You'll see in some of the homework, you can get complex numbers, you know? And I mean, that's not unreasonable. You would use the quadratic formula on the quadratic and get, you know, the quadratic. So I have 3. Now I encourage you to check, right? I mean, if you plug in minus 1, it's a 0. It should give you the 0. So it's 0. I plug in the minus 3, it gives me 0. I plug in the 2, it gives me a 0. Again, there's a lot of places on the exam where you can check your work. Okay, so that's a classic question. Okay, that's one you should be able to look at. Now here's another one. Let's take a look at this one. Okay. Now I just set this up as polynomial division. Now this is the classic. Watch. Let's see what happens here. This is the put it down here. This is the classic mistake. This is not in the form of a polynomial. So we've talked about this over and over. You have to write this out in the form of a polynomial, right? So this is the equivalent to if you said 1008, 1008. You can't just write 18. How would anyone know what you're talking about? You need it in the form of a polynomial. So I have to have all the terms here. So the most common mistake people make is they don't put in the terms, and then it doesn't all line up. Okay, so let's start the process. Why don't you give it a shot? Pause the video, see if you can work this out, and then come back and check with the video feed, and again, work through the problem. Okay, let me try. We have to match up the x cubed, that's the process, and I'm going to use x. I don't care about the 2. We're just trying to match up the x cubed. So what do I need to multiply x by to get x cubed? That's the question, right? What do I need to multiply? X squared, right? So I'm going to take x squared times this term now and put it down here. Okay, that's how it starts. So again, how does this happen? I take the x squared times the x plus 2. My x squared times x gives me the x cubed. X squared times the 2. 2x squared, that's just the consequence. That's all I need. The x cubed has to match up. Right? It has to match up. Now I'm going to subtract it. Put the minus sign in so you don't mess it up. Right? Drop the brackets, I don't need that. Now let's just add these together. All right? So x cubed minus x cubed, 0. Again, it has to be 0. It has to be 0. Okay, 0 minus 0x squared minus 2x squared is minus 2x squared. That's fine, doesn't matter. And that's good. So we're finished that. Now we just pull the terms down. Right, here's another term, pull it down. And the machine starts again. We have to crank the wheel a second time. So again, jump in and try this. Try the next round here. See if you can do this next step. And then again, restart the video and compare. Okay. So I have to knock out the minus 2x squared, and I'm using x. So what do I multiply x by in order to get minus 2x squared, right? What? Minus 2x. Notice how I'm lining up all the x cubed terms, all the x squared terms, all the x terms, and the constants. So minus 2x times the whole thing goes down here. That's just a process. Okay? Now I'm going to subtract. Okay, minus 2x is here. Minus x plus 2 is here. So minus 2x times x gives me the first term, minus 2x squared. Minus 2x times the 2 gives me that term. Okay, now we're going to add them together. Oh, okay, I'm subtracting it. Make sure you subtract it. Distribute that. Drop the brackets. Now I'll just add them together. Okay, minus 2x squared plus 2x squared is 0, and that's what I have to have. Again, I have to get the first term to knock itself out. 0x plus 4x, 4x. Good. Okay, bring your 8 down. and we start again here. We start again here. All right? So give it a shot. See if you can do it. Give it a shot. Pause the video and try to see how you do this. Let's see. So I have to match a 4x, right? I don't care about the 8, minus 8. I have the x here. I don't care about that. I need the x. What do I multiply x by to get 4x, right? What do I multiply x by? 4. So 4 times x is going to give me the 4x. So I'm going to multiply the whole thing and get this term here. Again, where does it come from? Take your 4 times your x plus 2 and multiply them together. 4 times x is 4x. 4 times 2, 8. Okay, now I subtract. Put your minus sign through so you don't lose it. Drop your brackets. Just make it cleaner. Okay, now add these together. 4x minus 4x, 0. That's what I have to have. That has to happen. Now, minus 8, minus 16. I mean, that's not good. For us, in factoring, it's useless. It's garbage. If it isn't 0, we can't use it in factoring. So why are there problems in the homework that aren't 0? I don't know. Just to practice polynomial division, because in your life, if you can't do this, you're a lesser person. You're not a real man, or even if you're a woman, right? I mean, I don't know. It's just for practicing. It's just for practicing. It's not useful for us. You cannot use it to factor if it's not a 0. It's a minus 16. So, okay, whatever. It's whatever. We have to deal with this. We deal with it. So that's all it means. It means I can write the answer out like that. The remainder is a minus 16. So it just means we break it down like this. So this is a sort of factorization. So that's our original polynomial, right? And you can write it, that's our term there. That's our quadratic part, it goes there. And that we could factor. But notice our caveat is we have this junk left over at the bottom, the remainder term. It just means it's not useful to factor. We just can't factor. This isn't a factor. It means we can write x cubed minus 8 like this. Life is good for some reason, and that's it. Okay, so whatever, it's just a homework problem. Don't panic about it. For us, in order to factor, and that's what I'm interested in on the exam, the remainder has to be 0. Because otherwise you factor this, and what does it come out to be? A 16? I don't care about a 16. I want 0. Okay? Now, I want to caution you. You can do this, and the book devotes some attention to it, and maybe you've been inflicted with it. You can do this symbolically, and it's called synthetic division. So instead of keeping track of all the x's and the x squares and the x's like I do, you write it in kind of a shorthand notation, and it's in the book. Look, I'm not going to ask you to do that in the course. These are just things that I think just add to your time and stress. In other words, if you read that and learn how to do it, it's going to take you a half hour. Right? Okay, half hour. Now think about that. You're going to do 10, 15 of these problems in your life. Synthetic division, the shortcut version, will save you about 5 seconds a problem. It's not a good use of time, right? It's just not a good use of time. I mean, you're going to be whatever major, nurse, biology, whatever you're going to be, business. I'm thinking synthetic division isn't going to happen a lot. So, I mean, okay, if you were a person that sat in an office and did polynomial division all day, every day, synthetic division would increase your productivity. For everyone else, it's just another thing that fills up the book that means things you have to learn. So just I don't recommend learning it. This is fine. For the test, you can do it like this. Any of the homework that says use synthetic division, just do it like this, okay? That's my thought. Okay. So we have a remainder here. That's fine. Whatever. It's practice with the polynomial division. All right. So what can you expect on a test? Polynomial division. You should know how to do polynomial division. And you should be able to use polynomial division. So I seed the problem by giving you 1, 0. You should use polynomial division to factor it, and you should be able to get the remaining zeros. Okay, that's what you need to be able to do. Okay, so take a look at the homework and good luck with all that.